Hey, what's up and how's it going? My name is Toby, and in today's tutorial we are going to learn how to place 3D AR objects at real-world locations using Lightship's brand new world positioning system. And for those who don't know, Lightship is a free plugin for the Unity engine that allows you to create amazing AR experiences. And so for those who have already been following this channel, you know that there's already a system for that, which is called Virtual Positioning System. And I've done a very extensive tutorial on that. And this one is the primary system to create location-based AR experiences that happen in the real world. However, this new system is also quite interesting, first and foremost, because it's very easy and quick to implement. So depending on the kind of AR experience that you want to build, WPS, the world positioning system, could be a great alternative. In this video, I just want to dive in and we want to create a very simple app where we will predetermine locations and place some objects there, and also make it possible for the player or for the user to place some objects in the real world. So the WPS, the World Positioning System, which has been introduced with ARDK 3.4, is, as far as I'm concerned, first and foremost thought to be an improvement over just the GPS location system in order to improve general location experiences. But it can also be very well used to just place an object and then lock it to this location. And the biggest advantage in comparison to the virtual positioning system that we've been already taking a look at is that you can just place objects anywhere. You don't need to have predefined locations that you need to 3D scan before even being able to use them, but you can just place objects at any kind of given GPS location, also give that opportunity to your player, to your user. But with that kind of flexibility, there are also some disadvantages. For example, the precision of the placement is of course not that great as compared to VPS, and you also don't have any predetermined 3D mesh that allows you to very specifically place down object at this exact location, but it's rather somewhere alongside this location and position. And you also, of course, don't have this kind of gathering spots, right? So if you think of some kind of game where people just meet at certain positions and they need to go there and then they might meet other players, so some kind of multiplayer game, this is of course also a bit more difficult with the world positioning system. But even with these kinds of disadvantages, the world positioning system is still extremely interesting, and that's why I wanted to take a look at it. So to get started, let's first of all create a new Unity project and call this one WPS tutorial, and just click create project. Then let's go to lightship.dev, the link is in the description, and copy the install link. Then we're going to go to our package manager and add a package by git URL and just copy and paste the link, click add. Then next up, let's go to our lightship.dev and create a new project, copy the API key, and then go into our settings and enter the API key. Next up in the XR plugin management, let's make sure to select Lightship and in all of our platforms. And then let's go to the build settings and choose iOS as our platform, or Android, depending on what you build. Then in our project validation, let's simply click on fix all. And now finally, let's begin by creating the scene. So create an XR origin and an AR session for that. And then delete our main camera, and now also choose our aspect ratio. So I'll choose the iPhone 11 and just reset the scale. And so next up, let's create a new empty object, call it WPS. But before we can start using it, we need to install it first. So do that and go to the link in the description. Just download it, go to the package manager, then add by tarbell, and then just select the downloaded file and it will install. So next up, let's add a few basic scripts here. So the AR World Positioning Manager and the AR World Positioning Object Helper. And let's set the altitude mode to camera relative with smart averaging, as this will make our life easier, as we do not have to calculate the altitude later on. So finally, we want to start scripting and create a new script. And let's just call this pre-place world objects like this and create it. Alright, so let's begin with the very first script, and first of all let's declare a few variables up here. So let's begin with some serialized fields. First of all, we want to have a list for our materials, so like this. And let's call this materials and just initialize it up here so we can later on just place some materials in there. And then we also, of course, need some kind of object that we want to place. So let's also make that a list and call this so a list of game objects and call this possible objects to place. Let's also initialize this one up here. I don't think it's 100% necessary to initialize this list up there, but let's still do it. And then next up, we want to create a new list. And for that, we will need to create a new struct. So let's first of all go down here and create new struct. So public struct, and let's call, struct. Let's call this lat long. And here we want to actually store the latitude and longitude locations. So this is kind of the GPS coordinates at which the possible objects to place will then be spawned, which we can predetermine in the editor. And so let's simply create two variables. So two doubles. The first one will be the latitude, and the second one will be the longitude. Like this. And to make it usable in the editor, let's also make this one serializable, like this. And then let's just put the struct here in the list. So it's a list of latitude and longitude. And let's just call this lat longs, like this. And let's also initialize it. Now finally, we need a reference to our managers. So we want to create a reference, first of all, to the AR World Position Manager. Let's call this Position Manager, and then we'll take another reference to the AR World Position Object Helper, this one. And let's call this Position or just Object Helper. Yeah, that's easier. Cool. So then finally, we'll just need a list with the instantiated objects. So let's create this. Game object and then instantiated objects like this. So also initialize it. So then it's quite easy. In our start method, we can simply say for each, and then for each let longs. So for each, let's call this GPS coord. We want to simply instantiate a new object. So let's create a new game object, new object. And let's say this one, we want to instantiate. We're going to go to the possible objects to place. And let's, for example, just take from our lat longs the index of the current GPS coordinate. So for example, the first coordinate will be 0, the second one will be a 1, so we just can't go through all of these GPS coordinates and then take a corresponding game object and to not go out of bounds. So for example, if we have more coordinates than game objects, of course we want to take the mod operator here and just going to take the possible objects to place and then the count, like this. So that means that, well, we will go for example, the first coordinate, and this will be the object 0, and then the 10th coordinate, let's say, if we imagine that we only had 9 objects to place, then we would just start over at the first object. So that's what the mod operator would do in this case for us. All right, so then let's go to our object helper like this, and we're gonna say add or update object. So now we're just gonna take our new object, and then we're gonna add, of course, the GPS coordinate latitude and GPS coordinate longitude, and the altitude is going to be 0, as we are using the smart averaging, so we don't need to actually set anything here. And then the quaternion.identity for the rotation. And as you might have already guessed, the add or update object method from the AI World Positioning Object Helper is the method that is finally placing an object at a certain GPS location so we can see it in the real world. So one more thing I want to do is I want to go ahead and debug. So let's say debug.log, and then we can take the $ and say edit, and then we can take the new object name, and we're gonna say with latitude, and then we're just gonna take the GPS code latitude and longitude. Just gonna say this gonna be the GPS coordinate longitude. So one more thing we want to do, which is quite important, is we want to check the status of the GPS. So for that, we want to go to the positioning manager, and we can go to on status changed, and we can simply subscribe to that and create a new method like this. So on status changed. And here we can very easily debug log status changed to, and then just obj. So this, we can simply rename this so it's a little bit more clear to status, like that. And so we can see whether we actually have a GPS connection and if we're actually tracking, because, well, the system, of course, is very much dependent on the GPS connection, or that you have a very good or good GPS connection with your phone. So let's also just delete this method, we don't need it. Okay, cool. So then let's go back to the editor. So back in the editor, we simply can drag our XR origin where our positioning manager and our object helper is attached to the script. And now we need to find a few coordinates that we're going to put in here, objects to place and materials. So for the coordinates, we can simply open Google Maps. All right, here we are. So then you can go to a position where you are located and, for example, simply do a right click and copy the latitude and longitude coordinates like this. And then let's paste the coordinates. So this is the latitude, and then we need to take the longitude and paste it down here like that. And so now we can actually copy and paste as many coordinates as we want. And as I'm just thinking, we will not need the materials list up here, as I was first thinking about just spawning cubes and then adding different materials to them. But I would say that we will rather just take some random assets and spawn them, so we do not need the materials. And then we just need to fill in the objects to place. So for that, I'll just import some kind of random assets that I'll put in there. So I'm just going to take this asset here and just import. And I also want to take this asset here. So these 4 dragons, they seem to be pretty cool, and simply just import. All right, so once that's done, we can simply go ahead and lock this inspector view here and just drag in our prefabs like that, for example. And so they will now be spawned in those corresponding locations. And yeah, please don't look these coordinates up, as they would reveal my actual position. But I'm sure you guys will not do this. So I really trust in you. So please do not, do not come here. All right, but nevertheless, there's only 1 or 2 settings that we can do now. So the first one would be to go to our main camera and just also unlock the view here, and go ahead and set the clipping planes to a higher number, something like 500 or so. Otherwise, the objects will just disappear if you are too far away. And then, of course, we can also go ahead and add the occlusion. So the AR occlusion manager, or even better, the Lightship occlusion extension. This one can just be set to the fastest and prefer environmental occlusion. And so what this will help is just to occlude the objects if they are too far away. However, for testing purposes, I would advise you to just disable the occlusion manager for now, because then you can immediately see whether some kind of objects are placed around you. And one more thing I would advise you guys to do is to add a script that's called zzzLog, and I'll put a link in the description, and it it will automatically print the debug.log statements onto your mobile device screen, so you can see, for example, whether the objects have been spawned or whether there's actually some kind of connection. Because, for example, if you, and this is also quite important to test this with Wi-Fi on, you will not have a good GPS position. So that means you will have to switch off your Wi-Fi, and only then it will have a good enough GPS position to actually place down these and show these objects. So for that, I'll put a link in the video description. Then let's just simply attach the zzzLog script to the game object. Cool. So now after saving and click on build and run this on our device, it should work in theory. And yes, for me it has been working quite well, but you also can see here in my example that I forgot to set the clipping planes to 500, so there's this weird dissolve effect. Cool, so as this has been working, next up I want to show you guys how actual users or players can place down objects at real-world positions. So for that we'll write another script. So let's click on our WPS object here. By the way, if I'll say VPS, I mean WPS. It's just because in my native language, German, and that's extremely confusing, but V is W basically. So V means W and V would be V. So it's a bit difficult for me, so please bear with me if I mispronounce that. Alright, so next up, let's find out how actually users or players can place an object at a real-world location, so we don't have to pre-place everything. Let's click on a WPS object here, and let's add a component and call this place object at location, like this, for example. And so, as expected, we are going to need a serialized field with references to the AR world positioning object helper, and let's call this again object helper, and another reference to the AR world positioning manager. So let's call this positioning manager. And then we'll also need a reference to the AR camera manager, like this. Oops, not this one, but this one. And finally, we're just gonna need a reference to a button that we'll create, which will then place an object once we select it, like that. And then finally, we can, for example, create the reference to some kind of game object that we're going to call object to place, like this. So then in the start method, let's go to the button and say on click. And then we're just gonna add a listener, and we're gonna create a new method here, and we're gonna call this method spawn on click, like this. I'm gonna add this method into the listener, like that. And so in this method, we first of all want to get the transform for the camera. So let's call this camera transform. And this is going to be the camera manager.transform, or better, let's get the component of transform, like this. And so then we'll need to create another method that is going to actually translate the camera position relative to the origin. And so then next up we'll need a new method that is going to get the geographic offset from the camera position. So it's basically translating the camera position into a latitude and longitude. So for that, let's create a new method, and let's create a tuple here. So it's going to return a tuple of two doubles, and we're going to call that get geographic offsets from camera position, like this. And let's take a vector 3 and let's call this one position. And let's create a new double here, and let's gonna call this latitude or just let offset like this. I'm just gonna take the position.z, and we wanna divide this by 111,000 like that. And just gonna take another double, and let's call this long offset, and this is going to be the position.x. And here we'll need to do a little bit more of calculation. So we're gonna again take the 111,000, and we're gonna multiply this by the cosine mathf.cosine of, and here we want to convert the position manager, will transform the original latitude, and we want to multiply this by mathf degree to radians like this. And so what this does, it's going to take the original latitude that is going to be calculated when you open up the app, and it's basically going to calculate the offset, so basically the distance or the direction that you went with your phone, let's say. So you open up the app, you go a few meters, and then it's going to calculate what this means in the GPS coordinates, so the latitude and longitude in relation to where you went with your phone after opening up the app, so from the origin. And then we want to return, of course, the lat offset and the long offset like this. Up here we want to call this method, so let's create a double with the lat offset cam, and another double with the long offset cam, and this is a tuple. And we're just gonna get the geographic offsets from camera position from our camera transform dot position like this. And then we want to create two doubles. So this is going to be the latitude, and this one is going to consist of the positioning manager will transform the original origin latitude, and then we're going to take the lat offset cam like this, and then we're gonna take the longitude, and this is going to be also the position manager will transform origin longitude plus the longitude offset from the camera, and the altitude, it's just going to be 0.0 for now. So then let's spawn a new object and call this new object like this. And we're just gonna say instantiate the object to place. And then we are going to take the position helper, so also the object helper, we call this. And then we're going to add our update object, and we're going to take the new object with the latitude, the longitude, and the altitude like this. And of course we're going to take the quaternion identity. All right, and then let's finally add a debug statement, so debug.log, and we want to say placing, or let's just quickly add a $sign here and just call this one placing object at latitude. I'm just gonna say the latitude, and we also can just take the name, so the new object name at latitude and longitude, so this one. And of course we could also do the same thing as we did here, so we could check for the status to change. Again, it's very important to have a good GPS connection and also to turn off Wi-Fi. So now let's delete the update method, we will not need it, and let's just simply fill out these fields in the editor. Alright, so back in the editor, we just gonna again drag in our XR origin here, so the object helper, the position manager. For the camera manager, we need to go into simply the XR origin and take our main cam. Then we'll need to create a button. So let's just go into UI and create a new button like this. Import the TMP essentials. Let's just go quickly into 2D view and zoom out, or maybe we can just click on the canvas, Shift F, like this. Then we're going to take the button and position it somewhere in the middle and put it a bit upwards, just increase width and height a bit, like that. I'm just going to call this one place. So then in our new script, let's just drag in the button, like that. And let's just choose some kind of object. So let's take a dragon or so and double click on that. Let's also reduce the size so it's not going to be too big. So let's make this 1.3. Depending on what kind of object you take, could be a different size like this. All right, so then let's save and let's also make sure that we'll deactivate the pre-place world objects. We could use both, but we just want to test this one. And also make sure that if you test this, just use debug.log to just regularly check if things are working well. All right, so let's build and test. And yes, indeed, if we hit the place button, there is actually an object spawning at our location. But as you might also have noticed while testing, well, the precision is not always the same. And depending on the GPS signal, the object might spawn a few meters away. So this is something we need to incorporate in our app and game design. And if we do that, we can create some amazing location-based experiences using the world positioning system. All right, but that's it for this tutorial. I'm very interested in your opinion. What would you rather use and why would you rather prefer the WPS system with this kind of pre-scanned meshes that is harder to set up, or would you prefer the world positioning system and why? What kind of app would you want to build with those? So I hope this tutorial was helpful for you guys and thanks a lot for watching and see you next time.